everyone. In this problem, we have well, I don't even know. Somebody pointed out to me that this is rather silly, but we have a lighthouse offshore, not right on the shore, and it is revolving, so we get 1 revolution per minute. We know that when the light is directed toward the beach, the spot moves up the beach as the course revolves. The house revolves, maybe. This one has all sorts of troubles. We want to know how fast the spot is moving when it's 12 miles from the point directly across from the light source. Sorry, this one has all sorts of awkward wording, but I will give you a picture. So we have, let's say this is the shoreline, and we have a lighthouse that's 5 miles offshore. So this is our lighthouse. And the lighthouse isn't moving, so I'm going to go ahead and label that 5 miles as fixed. We know that the lighthouse is turning around and around so that we get 1 revolution per minute. Okay, so if the spot is 12 miles away, so I'm going to go down since I have more room, so let's say the spot is directed at a point down here that's 12 miles away from straight across. We want to know how fast the light will be moving up the shoreline. So we want to know how fast this distance is changing. So let's call that x. Okay, so we want to know dx dt when x is equal to 12 miles. So when the spot is 12 miles away, how fast is it moving? This is the only rate we were given, 1 revolution per minute, and this is kind of a tricky one. I would just say here that 1 revolution per minute is telling us something about how fast the angle is changing. So we could rewrite that as 2 pi radians per minute. And then we just have to pick out some angle in this problem that we're looking at. So the way I've drawn it, it seems reasonable to make that our theta, which means this is a d theta dt, and then the only thing I would say here is that if the spot is moving up the beach, which it could be moving either way, but that's how I was picturing it. So if we're picturing it moving up the beach, then theta is actually decreasing. Theta is negative. This is headed that direction. So it doesn't really matter if you flip-flop, it'll just change the sign, but that's how I was thinking about it. Okay, so we need a function that relates theta to x and to 5. Oh man, I'm boring. This looks like another tangent to me. So let's say that tangent theta is equal to x over 5, opposite over adjacent, and we're looking for dx dt, so I actually like this fairly well how it is. You could multiply by 5. I'm going to do this one without. So the derivative of tangent theta is secant squared theta d theta dt, and the derivative of x over 5, remember that's the same as 1/5 x, so it's a 1/5 dx dt. Okay, now that I've done it, I don't love it because I don't know theta. So you can just go ahead and solve for theta. You could go back to your equation and say, okay, when x is 12, can I solve for theta? But you could also say, well, that wasn't that hard to take the derivative of. Maybe I do want to rearrange it. I'm going to go ahead and say theta is equal to the inverse tangent of x over 5. So yeah, we're looking for dx dt, but if we take the derivative with x by itself, we have thetas left over. This way, I'm going to get d theta dt equals 1 over 1 plus x over 5 squared. And then there's a couple of chains. One is, that's the derivative of inverse tangent. The derivative of x over 5 is 1/5. And then don't forget the dx dt, derivative of x. Okay, so I have d theta dt is negative 2 pi. I have x is 12. And then I have this extra 1/5. So to solve for a dx dt, I'm going to take my negative 2 pi, and I'm going to multiply by 5, so that's going to give me a negative 10 pi, and I'm going to multiply that by this 1 plus 12 over 5, which is 144 over 25, 12 over 5 squared. Okay, so if we plug all that in, I have a negative 10 pi times 1 plus 144 over 25, which is negative 212.37. I don't know why it thinks it wants to give me degrees, but I don't want degrees. That is how fast x is changing. So distance x is decreasing by 212.37 miles per minute, which is quite speedy, I would say. Okay, thanks for watching.